In this session, I am going to explain secured socket layer architecture. This secured socket layer is designed to make use of TCP to provide reliable end-to-end secure service. Secured socket layer is not a single protocol but rather two layers of protocol as shown in this figure. The Secure Socket Layer Record Protocol provides basic security services to various higher level protocols. The HTTP, that is Hypertext Transfer Protocol, which provides the transfer service for web client or service interaction, can operate on top of Secure Socket Layer. There are three higher layer protocols are defined in Secure Socket Layer. The handshake protocol, the chain cipherspec protocol, and the alert protocol. These secure socket layer specific protocols are used in the management of secure socket layer exchanges. There will be two important secure socket layer concepts are one is called as a secure socket layer session and other one is called as a secure socket layer connections. What is meant by secure socket layer connection? This is a transport that provides a suitable type of service. For secure socket layer, such connections are peer-to-peer relationship. These connections are transient. Every connection is associated with one session. Session, that is secure socket layer session, is an important association between client and a server. Sessions are created by the handshake protocols. Sessions define a set of cryptographic security parameters which can be shared among multiple connections. Sessions are used to avoid the expansive negotiations of new security parameters for each connection. There are maybe a multiple secure connections and also multiple simultaneous sessions between the parties, but this feature is not used in practice. There are a number of states associated with each session. Once a session is established, there is a current operating state for both read and write, that is, receive and send. In addition, during the handshake protocol, pending read and write states will be created. Upon successful completion of a handshake protocol, the pending states becomes the current state. There are number of parameters in session state that will be discussed one by one. One it is called as a session identifier. This is an arbitrary byte sequence chosen by the server to identify an active or resemblable session state. Peer certificate. This is X509.version 3 certificate of the peer. This element of the state may be a null. Next field is compression method. The algorithm used to compress data prior to encryption. Cypherspec. This will be specifies the bulk data encryption algorithm and a hash algorithm. Mainly this is used for MAC calculation. It also defines cryptographic attributes such as the hash underscore size. Master secret. This is a 48-byte secret shared between the client and the server. Is resumable. A flag indicates whether the session can be used to initiate for the new connections. A connection state is defined by the following parameters. The first one is called as a server and client random. Byte sequences that are chosen by the server and client for each connection. Server write max secret. The secret key used in MAC operations on data sent by the server. Next is client write max secret. This is a secret key used in MAC operations on data sent by the client. Server write key. This is the encryption key for data encrypted by the server and it will be decrypted by the client. Client write key. The symmetric encryption of key for data encrypted by the client and will be decrypted by the server. Initialization vectors. When a block cipher in CBC mode is used, an initialization vector will be maintained for each key. This field is first initialized by the Secured Socket Layer Handshake Protocol. Thereafter, the final ciphertext block from each record is preserved for use as the fourth with the following record. The last one is called a sequence numbers. Each pot will be maintains a separate sequence numbers for transmitted and also received messages for each connection. Suppose when a party sends or receives a channel side prospect message, the appropriate sequence number is set to 0. Sequence number should not exceed 2 to the power of 64 minus 1. Sequence Secure Socket Layer Record Protocol. This will be provide two services for secure socket layer connections. The one is called as a confidentiality, other one is called as a message integrity. What is meant by confidentiality? This is a handshake protocol defines a shared secret key that is used for conventional encryption of secured socket layer payloads. Message integrity. The handshake protocol, this will be defines a shared secret key that is used to form a message authentication code. Compression is optionally applied. Compression must be lossless and may not increase the content length by more than 1024 bytes. In Secured Socket Layer version 3, no compression algorithm is specified. The default compression algorithm is a null. The next step in processing is to compute message authentication code over the compressed data. For this purpose, a shared secret key is used. The calculation is defined as hash mac write secret concatenated with the pad2, concatenated with the hash mac write secret, concatenated with the pad1, concatenated with the sequence number, SSLC compressed dot type concatenated with the SSL compressed dot length, concatenated with the SSL compressed dot fragment. So where here this pipe symbol that will be used for concatenation. MAC write secret is a shared secret key. Hash is nothing but a cryptographic hash algorithm, either MD5 or SHA1. Pad1 is nothing but the byte 0x36 that will be repeated 48 times for MDF and it will be repeated for 40 times for SHA1. Pad2 is the byte 0x5c that will be repeated by 48 times for MD5 and it will be repeated for 40 times for SHA1. Sequence number that can be represented by sequence underscore num. SSLC compressed type is a higher level protocol. This will be used to process this fragment. SSLC compressed dot length. This is nothing but a length of the compressed fragment. SSL compressed dot fragment. This is the compressed fragment. That there will be two pads are connected in Secured Socket Layer version 3. and are exiled in HMAX. The secure socket layer version 3 MAC algorithm is based on the original internet dot for HMAC, which is used for concatenation. The final version of HMAX uses the XOR. The compressed message plus the MAC are encrypted using the symmetric encryption. Encryptions may not increase the content length by more than 1024 bytes, so that a total length may not exceed 2 to the power of 14 plus 2048. So this is the encryption algorithm or permitted. That is block cipher, stream cipher, that is algorithm, key size, that every they'll be shown in this table. FORTISA can be used in a smart card encryption scheme. For stream applications, the compressed message plus the MAC are encrypted. Here the MAC is computed before encryption takes place, and that the MAC is then encrypted along with the plain text or compressed plain text. For the block encryption, padding may be added after the MAC prior to encryption. This padding is in the form of number of padding bytes followed by 1 byte indicates the length of the padding. The total amount of padding is the smallest amount of such that the total size of the data to be encrypted is a multiple of the cipher's block length. To make the total an integer, multiple of 8 1 bytes of padding is added. The final step of secure socket layer record protocol processing is to prepare a header consists of the following fields. The first one is called content type. This is a 8 bits. Higher level protocol used to process the enclosed fragment. Major version. This is also an 8 bits. This will be indicates major version of secure socket layer. In secure socket layer version 3, the value is 3. Minor version. This is also an 8 bits. This will be indicates minor version in use. For secure socket layer version 3, the value will be 0. Compressed length, this will be 16 bits. The length in bytes of the plain text for fragment. The maximum value is 2 to the power of 10 plus 2048. The content types that have been defined are char, change underscore cipher dot spec, alert, landshake, and application data. The first three are the secure socket layer specific protocols. The content of the data created by such applications is a opaque to secure socket layer. This already explained. Thank you.